Alright, so in the previous video we have explained to you guys about machine language and assembly language, and we have said that if you guys want to write, say for example, here it says machine language for the Commodore 64 and 128 bits of the computer. So for example here, this specifically this machine language are written for this one. But what if you guys have a different computer architecture? Say for example you guys have a Toshiba computer, or you guys have a ASUS computer, if you have Intel, but this machine language is not going to work on your architecture, on your platform. That's what it, because it's a platform assembly language you guys can write. For example, it's ready for a specific say CPU. For example, if you wanna guys, because the memory architecture of this one's and this one's going to be different. For example, say it has a memory and it goes to CPU data to memory, this all fine, but as a computer programmer, when you guys write this code, it's going to work for only one platform, so as in assembly language. What's the solution then? What we can do to make it easier? For example, to make everything easier, then the programmers came in and with the idea of the C. So the C has uses compiler. C and C++, they use a compiler. If you look in here, they have a file .c. They use a compiler. We press the button compile when our source code, then it goes and creates the file, object file. So when it goes through object file, there is a file. We have a file 2, file 3, and through the linker here, you guys look in here, there is a linker. It creates the output. All right, so here we have a C++ source file, and here we have a compiler, and source file.c is, we have a C compiler here, then it goes there, it goes assembly file.asm. We have a C++ file .cpp. There we have C++ compiler. Then we have a C source file, is that we have a C compiler. Assembly file.asm is called assembler. If you look in here, that's why it's called assembler. Then it's got a relocatable object file library.lib, and it goes to linker. If you're looking here to linker, and if after this linker scripts.lst, it goes to ALF, dwarf absolute object file, ABS, it goes to object file, and it goes finally towards the simulator or hardware. So Intel absolute object file .hex. If you look in here, the final one is going to be Intel hex absolute object file .hex. So if you look in, this is a compiler, that's a C++ compiler, that's a C compiler, it goes to assembly compiler. So when you goes to see for example C++.cpp, you write your source code, when you guys execute that one, it compiles, it goes to, say for example, it goes to the linker, it creates the object file, and it goes to linker, and it goes to the CPU. So it manipulates all these zeros and ones. So this is called what happens if you write your program. Say for example, if you're compiling, when you go use compiler, it means that when you write something like, for example, C++, that's our say for example assembly language, that stays with that software or hardware. Say for example, if you're writing for Intel Windows 32-bit, it stays with Intel Windows 32-bit. If you have a Nintendo, if you write with one particular Nintendo, say for example 1990s, it's going to stay with that Nintendo. It's not going to go on the next Nintendo. Say for example, if you write your game with Nintendo, say for example 2015, and 2017 another Nintendo comes in, then your file can be compiled on this one, can be run on the new Nintendo, because you guys need to write totally new game for every Nintendo. So it's called platform. This is called platform dependency, because your source file, whatever file you guys writing, are dependent on that platform. And if you look in here, you have a source code, and you got preprocessor, then we have a compiler, assembler, and link editor. So you have this called object code here. So you have a source code, and then it goes to compiler, that compiler turns into assembler, then it goes library, then it goes to link editor here. So this is another example I can give you. It's a pre-processing. Say for example inside the C++, when you go on top, you guys adding your library is called is pre-processing. When you guys you're writing your source code, then the compilation translates the program into object file containing machine language code. So it translates all the program whatever you wrote into object file, and object file containing machine language code, and it goes to linker, and the linker handles merging and makes executable file. So you have a preprocessor, you have a compiling, and you have a linker, and after the linker it goes to the machine language. So this is the process of compilation, and the process of the, say for example, platform dependency is that when you guys write one program, say for example for Windows, you guys cannot write the same program for say for example Linux. You guys can't execute, there's no way you guys can execute on the Linux platform. So this is called platform dependency. So, and in the next video we're gonna show you guys interpreter, what is interpreter, and how inside the Java you guys, when you guys write your program, how it's gonna be platform independent. Understanding the platform independence in Java is very, very important, vital parts of the Java. As a Java engineer, you guys need to understand that how Java is a platform independent, how Java is not just binding to one platform, bound by one platform, our specific computer, our specific architecture, but it's for every platform and every architectures that you guys can see, is whether it's Intel, Asus, Toshiba, any computer, IBM computer, is going to be Lenovo computer, whatever computer you guys can see, that your Java runs with no problem. So that's what's called platform dependency, which we can see in the case of machine language, assembly language, C, C++, and platform independent such as Java language. And we're going to show you how Java runs on a platform independent. Okay, all right guys, that's it for this video. If you guys have any question or comment, leave in the comment box. Otherwise, I'll see you guys in the next video, and bye.